dehydration of alkenes. The first route that we are going to study is by using cold and concentrated sulfuric acid or fuming sulfuric acid. The route is cold and concentrated sulfuric acid or fuming sulfuric acid. So let us take a simple alkene, propylene, CH3, CH, double bond, CH2. So when I am talking about H2SO4, it means H plus, HSO4 minus. So as per Markovnikov's rule, HSO4 minus will go into the middle carbon. This double bond will break. HSO4 minus over here, and one hydrogen is going to get attached here. So a simple addition reaction. Okay. So you can call this compound isopropyl hydrogen sulfate. Iso word is coming because the hydrogen sulfate is attached to the second carbon. Isopropyl hydrogen sulfate. Okay. If you want,
Sir.
then you can have many products from this hydrogen sulfate. Number one is, if you heat it, then it loses H2SO4. If you heat it at temperature of 433 to approximately 443 Kelvin, it loses H2SO4. So this HSO4 and H is lost, and you can get back your propene. You can get back your propene. Okay. Also, if you boil, okay, if you boil it with water, water means HOH. If you boil this with water, then you will get back your alcohol. Basically, this process, boiling with water, is called hydrolysis. So what we do with this H of water, this HSO4 goes out. So minus H2SO4. So this HSO4 is not there. So the compound is CH3, CH, CH3. And here one bond is empty. This bond is occupied by OH. Okay. So this is isopropyl alcohol or propan 2. Okay. So this is basically your hydration of alkene. If you see, hydration has happened, one hydrogen and one OH group has been added, but we did all this stuff by adding H2SO4 first. Okay. So this is the first route. Suppose I take but1 in, and I want to convert it to but2 in. So but1 in is 1 2 3 4. So this is but1 in but1 in. Suppose I give H2SO4 into it, concentrated H2SO4. So here there will be HSO4 connected in the carbon which is 2 degree basically. Next I will use water to boil. Achha, one thing I have forgotten, you will when you will use this concentrated H2SO4, if you use cold and concentrated H2SO4, then this temperature will be cold. This temperature will be approximately 273 to 280 Kelvin, cold and concentrated. Now H2O, boiling H2O with it, then what it will give me? It will give me an alcohol over here. Now if I want to get my alkene back, then what I'll do? I'll basically employ dehydration, right? So dehydration is concentrated H2SO4. Okay, 170 degrees Celsius temperature. So this OH will go out and the hydrogen will be taken from the carbon which has least number of hydrogen, right? So this is the carbon having the least number of hydrogen, see CH2, right? 2 degree, and this is 3 degree. So 3 degree, from 3 degree carbon hydrogen will not be extracted. From 2 degree hydrogen is going to get extracted, and we will get but2ene, which is much stable alkene than but1ene. Okay. Okay. Our next process of hydration is HBO reaction. Full form is hydroboration oxidation. This reaction is basically a part of alcohols. So in alcohols, this reaction has to be studied in much more detail. But here also we'll study the reaction in detail, but not in the detail of actual mechanism. Okay. So see this. Suppose I use a propene. What is hydroboration? Hydroboration is basically addition of borane. What is borane? BH3. So normally BH3 remains as B2H6. So we normally use B2H6, okay, in presence of THF. We use B2H6 in presence of THF. THF is tetrahydrofuran and it is used as solvent. Now B2H6 means nothing but necessarily it is BH3. So you consider this B2H6 as BH3. Okay, like this you consider B2H6 is nothing but BH3. So suppose you are using BH3 over here. So BH3 can be written as H and BH2. H and BH2. When this BH3 gives away H, it gives it as H minus and BH2 plus. So H minus is going to get attached. Definitely negative part is going to get attached in the middle carbon as per Markovnikov's rule. So CH3, CH, here it is CH2, BH2. The reaction does not end here because previously boron had 3 hydrogen attached to it. Now boron has still 2 hydrogen attached to it. So still it is a boron compound with its 2 hands with hydrogen and 1 hand with the hydrocarbon group. Please try to understand, if I put another alkene over here, then In this alkene, another hydrogen is going to get added in this middle carbon. From where? From here, because here this boron is still containing some hydrogen. So this will again give another hydride ion, and what will happen? This new propene that you are using, CH3, CH, CH2. Here the hydrogen is getting added, and this boron is going to add into this carbon. A hydrogen is remaining with boron, and the other part is covered by hydrocarbon. So I am just writing that only. CH2, CH2, CH3. If you now see closely, still boron has another hydrogen left. So I can react it with another molecule of propene. And after this gets added, same kind of reaction will happen. This hydrogen is going to get displaced from here. And here also there will be a hydrocarbon group similar to this one and this one. So this is nothing but trialkyl borate. So this one can also be written as like this: CH3, CH2, CH2 whole thrice B. So ultimately what happened, in the borane problems on HBO. The first question. দেখো আমরা যদি ফার্স্ট কোশ্চেনটা দেখি, একদম ফার্স্ট কোশ্চেনটা, তাহলে আমাকে ফাইনাল প্রোডাক্ট জানতে চেয়েছে, ঠিক আছে, আমাকে অন্য কিছু জানতে চায়। তো আমরা জানি HBO যখন হবে there will be water addition and it will be anti-organic of water addition. তাহলে এটা খুব সিম্পল কোশ্চেন। তাহলে অ্যান্টিবায়োটিক অফ মানে একদম টার্মিনাল যে কার্বনটা, বাইরের যে কার্বনটা আছে সেখানে OH লাগবে, ব্যাস শেষ। নেক্সট এরটাও দেখো অ্যান্টিবায়োটিক অফ, আমরা জানি তো তার মানে এখানটায় OH লাগবে, এখানে নয়, CH3 যেখানে আছে সেখানে OH লাগবে না, সেখানে H লাগবে। অ্যান্ড ইট ইজ আ সিন এডিশন, তার মানে তোমাকে এখানে দেখাতে হবে যদি এইটা যদি এই সাইডে হয়, ধরো এটা OH, OH তো লাগবে এদিকে, তাহলে এখানে যে H টা আছে সেটাও একই সাইডে লাগবে, ওয়েজ এন্ড ড্যাশ ফর্মুলা, ঠিক আছে? আশা করি এটা সবার কাছে ক্লিয়ার। তো নেক্সট কোশ্চেনটা যদি আমরা দেখি, এই কোশ্চেনটা এখানে BD3 দিয়েছে, ঠিক আছে, BD3 মানে এখানে ডাইট্রিয়াম আছে। তো এখানে তার মানে আমাকে জানতে হবে অ্যাটলিস্ট ভেতরে রিঅ্যাকশনটা হয়েছে কিভাবে, শুধুমাত্র এইচ আর ওইচ বসিয়ে দিলে এটা গল্পটা হবে না। তো আমাকে সবার ফার্স্টে যেটা বুঝতে হবে যে রিঅ্যাকশনের দুটো পার্ট আছে, একটা হাইড্রোবোরেশন, একটা অক্সিডেশন। তো ইফ আই গো ফর হাইড্রোবোরেশন, তাহলে আমরা ক্লিয়ারলি দেখতে পাচ্ছি প্রথমে যে হাইড্রাইড গুলো অ্যাড হয়েছে সেগুলো কিন্তু BH3 থেকে অ্যাড হয়েছে হাইড্রাইড গুলো। তাহলে আমি যদি BH3 এর জায়গায় যদি BD3 দিয়ে দিই, তাহলে তোমরা ঠিক করে দেখো এখানে যে প্রথম হাইড্রোজেনটা অ্যাড হয়েছে, ফার্স্ট হাইড্রোজেনটা, এটা তো এই BH3 থেকে এসেছিল, তাহলে এখানে তো ডি অ্যাড হবে না, এখানে তো এইচ অ্যাড হবে না, এখানে তো ডি অ্যাড হবে। তাহলে যদি ডি অ্যাড হয়, ঠিক আছে, যদি ডি অ্যাড হয় তাহলে ডিটা কোথায় অ্যাড হবে, মাঝখানের কার্বনটাতে ডিটা অ্যাড হবে, ঠিক আছে। আর ডান দিকের কার্বনটাতে যে ওইচটা অ্যাড হয়েছিল সেটা তো অ্যাড হয়েছিল একদম লাস্টে, H2O2 OH মাইনাসের জন্য, সেটার সঙ্গে তো BD3 এর কোনো রিলেশনশিপ নেই, তাহলে ওটা আমি এইখানে দিয়ে দেবো। ওকে, আচ্ছা এবার আমি 5 নম্বরেরটা করে দেবো, তারপরে 4 নম্বরেরটা তোমরা করবে। তো 5 নম্বরেরটা একটু আলাদা, খুব ডিফারেন্স কিছু নেই। দেখো প্রথমে যে BH3 যে রিঅ্যাকশনটা হয় ওটা তো সেমই হবে, মানে ট্রাই অ্যালকাইল বোরেন তো এখানেও তৈরি হবে। তারপরে যখন CH3 COOH দিচ্ছ, তখন যেটা হয়, আগের বার OH লেগে গেছিল, এই ক্ষেত্রে শুধুমাত্র H লাগে। তার মানে এইখানে তো একটা H লাগবে, কার জন্য? BH3 এর জন্য। আর তারপরে এখান থেকে CH3COO মাইনাস আর H প্লাস এই জিনিসটার মধ্যে দিয়ে শুধু Hটা এখানে লাগবে। সো দিস ইজ বেসিক্যালি হাইড্রোজেনেশন অফ অ্যালকিনস টু অ্যালকেনস। ঠিক আছে? আর এটা এদিক থেকে বোরন ট্রাই অ্যাসিটেট তৈরি করবে। ঠিক আছে? তো দিস ইজ বেসিক্যালি ফর্মেশন অফ অ্যালকিনস টু অ্যালকেনস। CH3COOH যদি দেওয়া হয় হাইড্রোবোরেশনের পরে, উইল গেট অ্যালকেনস ফ্রম অ্যালকিন। হয়ে গেল? এবার তোমরা নাম্বার 4 পড়ো। So this is number 3, hydration. তো ডাইরেক্ট ওয়াটার অ্যাডিশন তো পসিবল না, কারণ আয়ন ফর্মই করে না ওয়াটার। So what we do is we add some Lewis acids. So you can add dilute H2SO4, no problem. Or you can add BF3, which is a Lewis acid. Okay. Phosphoric acid you can use. Okay. So in this case, what will happen? Let's understand the mechanism first here. Because this is a very simple mechanism and established in each and every textbook. CH2. Okay. So first of all, see, when you are giving acid, the water adds with acid. Water adds with this acid H plus and forms hydronium ion. So hydronium ion comes in front of this alkene. Okay. Now if you see, this water is this hydronium ion is having a positively charged species. Okay, that is oxygen is positively charged. So when oxygen is positively charged, then we have to neutralize this positively charged oxygen. So how it is neutralized? So this can be neutralized by this bond. This bond goes up to this, neutralizes this oxygen positive charge. So definitely there is a H plus over here. So this H plus is again electron deficient. This electron is satisfied by this bond, because whenever this reagent comes, there is an electromagnetic effect that takes place, and this bond shifts over here. As soon as this bond shifts over here, this gets a negative charge and this H plus attacks over here. So you have to understand the sequence. I am repeating. This bond neutralizes this positive charge in the oxygen. So left, this H is left with no electrons, so H plus. This bond shifts to the terminal carbon, negative charge, and this hydrogen satisfies this negative charge. And when this bond has shifted to this terminal carbon, here in this middle carbon, there will be a positively charged species. Okay, like this. And plus, if you see H2, what happens to this H plus? This H plus has added to this terminal carbon. Okay, so here we can see 2-degree carbocation is formed, and there cannot be any shifting after this, because 2-degree carbocation is already very stable, and you cannot form any 3-degree carbocation from this species. Okay, so now after that, I am having lot of water in it, so I can draw water like this. So water always has their lone pair with it, and here you can see this positively charged over here. This lone pair is going to attack like this, and if you see, the species that is going to get formed is this oxygen over here, H, H, and as this oxygen has donated its lone pair to this positively charged carbon, so this positively charged carbon is neutralized. This oxygen gets a positive charge. As soon as this oxygen gets a positive charge, same kind of mechanism happens as it happened over here. This positively charged oxygen has to be neutralized, can be neutralized by this bond, and with a elimination of a proton, which you can call deprotonation, loss of proton, and you will be left with only OH in this middle carbon. So in overall, if you see in this hydration, this was the alkene. I had added H2O and H plus, some acid, and I have got my OH in the middle. So I have got an isopropyl alcohol. Very clearly I can see this is a Markovnikov addition. Now I am giving you a problem based on this. আমাদের fourth process is AMDM process. Alkoxymercuration. Sorry, not AMDM, OMDM. Oxymercuration, demercuration reaction. Oxymercuration, demercuration reaction. So, mercuric acetate in presence of water and THF solution. So, suppose this is the alkene. The first step of the reaction is addition of mercuric acetate. So, acetate is written as OAC. So, don't get frightened when you see some OAC in the question paper. Mercuric acetate, tetrahydrofuran and water. So, first of all, RCH, CH2, OH is added over here. And here we are getting HgOAC. This is the first step. So this is oxymercuration step. So please understand one thing. This OH is coming from your water. Why this is important? Because sometimes question may be given as D2O. So you have to write CH and with that OD. After this, we have to go for demercuration. That means this part you need to remove because OH is already added. So demercuration is carried out by hydrogenation or reduction. So this is done by NaBH4 in alkaline medium NaOH. Okay. So here you can see this hydrogen is going to reduce this part. So this is simple hydrogenation reaction. Everything else remains same. Here another H is added. So here also if there is a NaBD4 given, then here there will be a D. Okay. So you need to understand the OH is coming from water and the H is coming from NaBH4. Okay. So these are the nuances that you need to understand. And you can clearly see in this total addition that this has happened as per Markovnikov's rule. So this is a Markovnikov addition. So except HBO reaction, every other reaction we have studied is simple Markovnikov addition. Except HBO reaction, every other reaction we have studied is simple Markovnikov addition. Okay? So based on this, let us do some questions. Number 1. Now this nitrosyl chloride has a special name, it is called Tilden's reagent. The reaction is very simple. NaCl can be broken as like this, NaCl. So this NO part is positive and this Cl part is negative. Okay. So you can use NaCl or NoBr, anyone. So for addition of this nitrosyl group into the alkene we are talking about. So suppose we have an alkene like propene and we want to add this Tilden's reagent. So this negative part is going to go in the middle as per Markovnikov's rule. So this is Cl and here will be having NO. Okay. So this is the addition of Tilden's reagent, very straightforward reaction. Next we will be doing important reaction that is called Diels-Alder reaction. This question was asked once in NEET examination. Diels-Alder reaction. So this is basically reaction of an alkene with alkadine. So first we will draw an alkadine. CH2, CH, CH, CH2. So please first understand if this kind of reactions are given, that is diene plus alkene. So you can see a diene and you can see some other compound with a double bond. Then there will be Diels-Alder reaction, and how you will proceed with this reaction to get the correct answer. So please see how I am proceeding. This is the alkene. So first of all, what we will do is this pi bond is going to get broken like this. So when pi bond is going to get broken, one electron from this bond is going to go to this carbon, another electron from this bond is going to go to this carbon. So one hand of this carbon is empty now, another hand of this carbon is empty. Okay. Similarly, do the same kind of exercise in this. Same kind of exercise. So now if you see all the carbons in all these reactants are having one hand free. Now if you see this carbon and this carbon, they are together already bonded, and if they are having one hand free, they can form a double bond over here. So CH double bond CH. I am talking about these two carbon. Next if we see, there is a CH2 over here, but it is having one hand free. Similarly, here there is a CH2 having one hand free. Here there is a CH2 having one hand free. Here there is a CH2 having one hand free. So you can easily join this. So this will result in a cyclic compound, and this is, as you can see, this is nothing but cyclohexene. Now what I want you to do is use the same kind of operation that I have done and do this problem. Try to find out the product of this problem. Same kind of operation that I have done. So I am giving you same kind of reaction again. Here is a diene. The same kind of reaction in this reactions. The first kind of reaction that we are going to do in oxidation is formation of epoxides. Epoxide formations. So let us take an alkene. This is alkene. if you use oxygen for oxidizing it, very small amount of oxygen is required in presence of silver, and the temperature will be from 200 degrees Celsius to 400 degrees Celsius, 473 Kelvin to 673 Kelvin. Silver catalyst is required. One of the bond of this double bond breaks, that is the pi bond breaks. Okay. So these hands are occupied by the lone oxygen. Oxygen requires two valencies satisfied by two of the carbon sand. So these are called epoxides. Okay, this is called epoxides, or these are two kinds of names are there: epoxide and oxidants. Okay, two kinds of names are there. You can also call them oxidants. The same reaction can also be carried out in presence of any peroxy acids. Peroxy acids means like, you know, if there was COOH, it would have been normal acid. But if there is 2OH, then it is not normal acid. This is a peroxide, peroxy acid. This is peroxy acid. So when peroxy acid adds to this, the same kinds of compound is formed, ekdom same kind, like this. Plus, so this one of this oxygen gets added over here, and the other part remains as it is. So this remains as acid, normal acid after this, after the reaction. Okay. So peroxy acids can also be used in presence of to carry out this reaction, and in place of Ag you can also use peroxy acids. Okay. So this is formation of epoxides or oxidants. So ozonolysis involves cleavage of alkenes. You need to remember this. Ozonolysis involves cleavage of alkenes. So alkenes basically gets broken while this ozonolysis happens. So we'll take the simplest alkene to understand the ozonolysis first. So let us take simplest alkene means ethene. So first of all, there will be ozonite formation. This is also called molozonite. Ozonite formation. O3, in presence of certain solvents, you can use CCl4, you can use CH2Cl2. So this is done in a very cold temperature. Very cold temperature. Okay. So the temperature is approximately 196 to 200 Kelvin. So you can see it is very cold. What will happen? In ozonolysis, both this double bond is going to get broken because you have to insert oxygen. So this is the way the ozonide is formed. So this is called ethylene ozonide. Okay. In this ethylene ozonide, next there is a process called reductive hydrolysis. There is a process called reductive hydrolysis. Reductive hydrolysis basically means this hydrolysis, lysis. What does lysis means? Lysis means breaking. So ultimately this structure is going to get broken, and this process is done by reduction. That is what it is said. So we have to go for reductive hydrolysis. This is done by various reagents. One such reagent we are doing over here is zinc water. So zinc water, as we know, zinc and water, if they react together, they are forming hydrogen. So hydrogen can take away oxygen via chemical process that is called reduction. So this kind of hydrolysis is called reductive hydrolysis. Sometimes it is also called reductive cleavage. So how to show this? This is shown like this.
ওই ওয়াই ভাবে কেটে নেব।
Yes, yes. So you have to draw this Y over here. This oxygen is taken away. Other things are remaining as it is. So here if you see, this is H2CO, and here also it is COH2. If you can see, this carbon is having only 3 bonds and oxygen is having 1 bond. So one bond will be formed in between them, so to form the double bond. So if you see this, this is methanal formaldehyde, methanal or formaldehyde, and this is also formaldehyde. So because this was a symmetrical alkene, both the sides are having same number of carbon atoms and hydrogen atoms, so definitely it will form same compounds after ozonlysis. But suppose I do the same ozonlysis with, say, this one. So again if I go for ozone, CH2Cl2, say 200 Kelvin, so it will form first the ozonite. Next is I have to form this Y to undergo reductive cleavage. And see here what we get, CH3, CH2CO plus H2CO. Here also you can see carbon is having 3 hands and oxygen 1 hand, so you have to increase one double bond. Here also you have to increase one double bond. Okay, so this is how ozonlysis occurs. Ozonolysis, this lysis word is basically due to this breaking. Lysis means breaking. So this breaking of alkene is happening over here, and that is why we call it ozonolysis. Okay, so this is basic theory for ozonlysis. By using this method you can do ozonlysis for all the compounds, all the alkenes. After this we will be doing some problems. So alkenes এ substitution reaction হয়, definitely substitution reaction will not be participated by your pi bond, it will be participated by the sigma bond. So see, if we take this compound, so as pi bond is not going to participate in the substitution, so this part is not very important while I am talking about substitution reaction. Now how this substitution reaction can be carried out? If you use chlorine at a very high temperature, substitution means you have to form free radical. Free radical requires very high temperature, it requires energy, as simple as that. So that is why this kind of temperature is required, 400 500 degrees Celsius, where this carbon is called allylic carbon. This carbon is called allylic carbon. Allylic carbon means carbon after double bonded carbon. So then it will undergo substitution reaction like this, CH2Cl plus HCl. So suppose I have been given like this, Cl2 773 Kelvin. So if you look at this, there are two allylic carbons over here and here. So there will be two substitution sites. So like this, here there will be a chlorine and here also there will be a chlorine. So this kind of substitution reactions are called allylic substitution reactions. Allylic substitution. Next is, this allylic substitution reaction can also be carried out in presence of a special reagent called NBS, N-bromosuccinimide. What is NBS? CH2, CH2, C double bond O, C double bond O, NBr.
স্যার এটা কি বললে অ্যালাইলিক সাবস্টিটিউশন?
This is N-bromosuccinimide. If you add propene to it, then also the allylic carbon of this propene, that is this hydrogen, is going to get substituted by the bromine. And we will get back NH. This hydrogen is going to replace over here. This compound is called succinimide, and this is called N bromo. Nitrogen bromine is there, so N bromo succinimide. So in short, it is called NBS. In short, it is called NBS, N-bromosuccinimide. Okay? So this is called, all these reactions are basically allylic substitution. This allylic substitution can also be carried out in presence of other reagents like SO2Cl2, sulfuryl chloride, or butyl hypochlorite. What is butyl hypochlorite? I am writing over here. So this is butyl hypochlorite. Okay. So overall, these are allylic substitution reactions of alkenes by cold KMnO4, very dilute 1% alkaline. So whenever cold KMnO4, this is used as a test for any unsaturated hydrocarbons. This is called Bayer's reagent. And this test is called Bayer's test. So in this test, basically this pink color of KMnO4 gets decolorized. This KMnO4. Cold, very cold temperature is used, 298 to 300 Kelvin. So you cannot heat it much further. So basically it is hydroxylation reaction. You have to, if you see, this is two hydroxyl groups. So H2C, OH, CH2, OH. This addition is nothing but syn addition. This addition is nothing but syn addition. Okay. And very important thing, if I use another reagent in presence in place of this alkaline KMnO4, suppose I use HC triple OH, that is performic acid, then the addition will be anti-addition. So that means one OH from this side, another OH from other side. This one you can better write it like this: CH2 CH2, here one OH, here another OH. Here the oxidation is from alkene to aldehyde. So this can be done. Reagents are like periodic acid HiO4, then lead tetraacetate H3COO, lead, or sodium periodate NaIO4. So if these are the reagents, then same products are formed. Okay, same products are formed. That is the acid that we have done. So these reagents will give you acids that we have already done. Next is there are some special reagents like Lamix reagent. Now what is Lamix reagent? Lamix reagent is sodium periodate plus KMnO4 or OSO4 in traces. If you use this reagent, then suppose this is the alkene, you use Lamix reagent, you will get oxidative cleavage and two aldehydes like this for Lamix reagent. Okay. Next is another kind of reagent is used, PD plus UCl2. PD plus UCl2. So this is used at a temperature of 323 Kelvin in presence of air. When this reagent is used, there is a process name that is called Wacker process. So H2C double bond CH2 plus PdCl2 plus H2O gives CuCl2 323 Kelvin O2 CH3CH plus Pd plus 2HCl. So here what happens is this Pd first reacts with CuCl2 and you get PdCl2 plus Cu2Cl2. Okay, and this Cu2Cl2, if you, I'll write this again, Cu2Cl2 gets added with HCl and O2 to give CuCl2 back plus H2. Okay. Because this reaction already produces this HCl, so which helps in regeneration of CuCl2. So first you use CuCl2, that is going to form the PdCl2, and ultimately if you see PdCl2 gets converted to Pd, the HCl formed reacts with Cu2Cl2, and that is why you see the oxygen is added, which will give you the CuCl2 back. So ultimately you get your catalyst back and you can reuse it again. So this is for aldehydes. You can use the same compound, same reaction for formation of ketone also. So let us see the formation of ketone. So if you use CH3, CH double bond CH2 and use the same reagents PD CuCl2 323 Kelvin O2, then you will get ketone, because at this time this carbon is going to get your the this carbonyl group. So this is how the reaction happens, totality. If you want to understand it little further, you can also understand like this, that there is this hydroxylation addition is there over here, and after that this aldehyde gets formed. First you will form diol, and then you can form the aldehyde. Similarly over here also you form diol, and then you will get the aldehyde. Okay, so this is the end of the oxidation reactions of alkene. Like S2Cl2, sulfur monochloride. কিভাবে? দেখো দুজনের দুটো একটা হাত খালি, সব কটা কার্বনের। এখানে সালফার ঢুকিয়ে দাও, সালফারের দুটো হাত থাকে, এখানে ক্লোরিন ঢোকাও, এখানে ক্লোরিন ঢোকাও, সবার হাত ফুলফিল হয়ে গেছে। দিস ইজ মাস্টার্ড গ্যাস, ঠিক আছে, পয়জনাস, এবং দিস ওয়াজ ইউজ ডিউরিং ওয়ার্ল্ড ওয়ার 1, ঠিক আছে, দিস ওয়ার মানে ওয়ারে ইউজ করা হয় গ্যাসটাকে, ঠিক আছে, দিস ইজ মাস্টার্ড গ্যাস।